Angle addition and angle bisector. So the angle addition postulate says that if K, so point K, is in the middle of the interior of angle HIJ, so that's this big angle here, HIJ, okay, then this means, right here, this means the measure of angle HIK. So whenever you see this lowercase m in front of angle, that means degree measure of that angle. So the measure of angle HIK plus the measure of angle KIJ has to equal the measure of angle HIJ. It's just like the segment addition postulate, where part plus part equals whole. The opposite is also true. If HIK plus KIJ equals HIJ, then K is in the interior of the large angle. Essentially, we're proving it backwards. First example here, if the measure of angle AOC is 70, the measure of angle AOB is 1/2 times the sum of 2x and 20, and the measure of angle BOC is x, then we need to find x, the degree measure of angle BOC, and the measure of angle AOB. Well, using the angle addition postulate, I know that part plus part equals whole. So this first blue part, AOB, is 1/2 parenthesis 2x plus 20 plus the other part, which is in green, x, equals the whole thing, which is 70. These are algebra skills. Distribute. 1/2 times 2 is 1. X. 1/2 of 20 is 10. Okay. Combining like terms. 2x plus 10 equals 70. And we're going to solve for x here. Subtract 10 from both sides. So x equals 30. I can put that, our answer there. If x is 30, then the measure of angle BOC equals 30 degrees. Okay, I'm just plugging it in, okay, for x. And the measure of angle AOB, okay, 1/2 2x plus 20. Well, that's 1/2. 2 times 30 is 60, plus 20 is 80. So the answer is 40 degrees. And we have the idea of an angle bisector, just like bisecting a segment. So by definition, a ray that divides an angle into two congruent angles, okay, that is an angle bisector. So if we look at the picture, anytime you see a single line in a corner, okay, that means they are congruent. You could also see two dashes like this. Okay, that's another way of being congruent. The other way is if we go like this, there's a line here, and if there's a little tick mark that way, that also means they are congruent. Or if there are two tick marks there, something like that. Anytime you see the same symbol in the corner, in both corners here, that means they are congruent, which implies that XZ, ray XZ, would be the bisector of angle WXY. We'll do one more example here. So example 2 says ray FG bisects angle EFH. Okay, since FG, okay, right here, this guy, bisects angle EFH, that's this large angle, okay, I know by definition of bisector that EFG is congruent to GFH. Anytime we see that, those angles are going to be the same measurement. So let's look at our following parameters. If the measure of angle GFH is 1/2 times the difference of 10x and 20, and the measure of angle EFG is 3x plus 25, then we need to find the following. Okay, first of all, we know that those two are congruent. Okay, GFH, we'll use green. GFH has to equal. I'm going to grab a different color here. Has to equal EFG. Okay, so let's set them equal to each other to solve for x. I've got 1/2 times 10x minus 20 has to equal 3x plus 25. Here, algebra skills tell us to distribute. I get 5x minus 10 equals 3x plus 25. Okay, multiplying by this fraction means dividing it by 2. Okay, variables to one side, constants to the other side. I am left with 2x equals 35. And to solve, so x equals 17.5. That's okay, we can have decimals there. Okay, the measure of GFH, that's our green angle. Okay, we're going to plug that in for x, 17.5 minus 20. And your handy dandy calculator will tell you that GFH equals 77.5. Since it is congruent to GFH. Oh no, that's the one we just found. Okay, since it is congruent to EFG, there we go, EFG, it's our red one, we know that this is also 77.5, which then tells us that our larger angle, EFH, we just take twice that value, and we get 155. These should all have degree symbols on these too. Don't forget that. We're talking about an angle measurement. Come on, Mr. Weiss. Okay. Okay. This last one might get a little tricky. Okay. Remember, we want the measure of angle IFE. That's this angle here. We've got on our screen, we've got a straight line. Okay, IFH, it's a straight line. And recall that the degree measure of a straight line is 180 degrees. Okay, the angle sum, so the whole thing has to equal 180. If I have EFH, which is 155, and the whole thing is 180, then I know that the remainder has to add up to 180, so it is 25 degrees. These next two examples I want you to try on your own. and we will talk about them next class period.